Okay, so today what I would like to do is to go over single replacement reactions. So when you have a single replacement reaction, you have an element replacing another element in a compound. And it can either be a metal replacing a metal or non-metal replacing a non-metal. So my analogy here is that there's this really cool guy that comes to this dance, and maybe you're here with your girlfriend, possibly dancing, and this is your buddy who's really cool, and he comes along and he asks your girlfriend to dance. Then before you know it, you notice that he's like swinging her over his head, and everybody's like watching, and they are now, it looks like a couple, and you're off here by yourself. So in order for this reaction to happen, your friend obviously has to be more cool. So when we're talking about elements cannot be more cool, but they can be more reactive. So here, A, if it is a metal, it will replace B, which is also metal, and then A will end up with C in a compound and B will be by itself. If A is a nonmetal, it will replace C, which is also nonmetal. C will end up by itself, and B and A will be a compound. Okay, so we're going to be using the activity series, which is on the reference sheet, which is under today's announcement, to figure out if these types of reactions will occur. So on your reference sheet, you should see this activity series. And this will list the most reactive. This would be like the coolest element would be lithium. It can replace anything below it. Silver is like the least cool. So the higher the element is on the list, it can replace anything below it. So if the element by itself is higher, the reaction will happen. If the element by itself is lower, it will not happen. Okay, so you're going to have to use the activity series to determine if this reaction will occur. And you're going to write the formula for the ionic compound that's being formed as a product using the charges of the ions. And then you're going to write the symbol for the element being replaced, remembering which elements are diatomics. Okay, so let's look at this reaction here. We have aluminum and hydrogen chloride. So I'm actually going to go out of this so I can ink on here. And if we look at it, aluminum is right here on our activity series. And hydrogen, so you notice hydrogen is on the same side as aluminum, so it's below it. So this means that this reaction will occur. So aluminum's going to come along, it's going to kick out the hydrogen. Hydrogen is by itself. When it's by itself, it's diatomic. And then aluminum chlorine are going to form a compound. Remember, aluminum's +3, chlorine's -1. Do the crisscross, and that will give you AlCl3. And then we just have to balance it. So we would balance it by putting a 6 here. This would be a 2 here, a 3 here, and a 2 here. So let's look at another one. Here we have iron. So iron's here, and it's not replacing sulfate. Sulfate's not on the activity series, but it's trying to replace copper. Iron is higher than copper. So iron's going to come along. It's going to kick out copper. Copper, when it's by itself, is just Cu. It's not a diatomic. And then we can assume iron's going to have a +2 charge. So it'll be FeSO4. So this reaction will occur. Okay, let's look at this one. Now, if you look at this one, you don't see this on the activity series, but I'm going to pull up your activity series that's on your reference sheet. And if you notice here, fluorine, chlorine, bromine, and iodine are on the right-hand side of the activity series. So your elements have to be on the same side of the activity series as each other to be able for the reaction, for them to replace each other. So remember, it's either going to be a nonmetal replacing a nonmetal or a metal replacing a metal. So if we go back to our problem, we have fluorine is trying to replace chlorine. So they're on the same side of the series. Fluorine is higher than chlorine. So fluorine is able to kick out chlorine. This will leave chlorine by itself. It's diatomic, so it'll be Cl2. And then when hydrogen is acting like a metal, it's a +1 charge. Fluorine is a -1 charge, and that will form hydrogen fluoride. Okay, so that's how to predict the products and then how to figure out if the reaction will occur. So I want you guys to try some of the ones on your worksheet, and I will just go out of this and I'm going to pull that up and I'll show you just how to approach this. Okay, so this is your worksheet you're going to be working on for single replacement reactions. And when you're doing these, I want you to focus on the reactant side of your equation in each case. So you don't need to worry about the S and AQ. What I want you to do is focus on the compounds, the element in the compounds. So you need to look at your reference sheet and look for the element by itself. In the first case, you have lithium. So we're going to look for lithium on our reference sheet. Lithium's up here. And then you want to look for something that's on the same side of the series as lithium. So you have silver, nitrogen, and oxygen. The only thing you're going to see on the left-hand side of the series with lithium is silver. Lithium is obviously much higher than silver, so this reaction will occur as a result. And then you could balance the equation. So if the reaction does not occur, you would put down no, and you can leave it, or if you just want to continue practicing with balancing equations, you could still practice it. Still balance it. Okay, so let's look at another one. So here we have calcium and liquid water. When this occurs, what is happening is calcium is trying to kick out hydrogen in the water molecule. So remember, water is bonded like this with the two hydrogens bonded to the oxygen. So calcium's coming along trying to kick out that hydrogen and leave in the hydroxide. So if we look at our activity series, we're going to notice that calcium and hydrogen are in the same side of the activity series. So let me bring that up. Let me erase this. So we look for calcium, and then we look for hydrogen. So calcium is higher than hydrogen on the activity series. So this reaction will occur. Now, in a problem up here, I just want to show you one where it will not occur. We have nickel and we have calcium. And if we look at our activity series, we can see that calcium's up here, nickel is all the way down here. So this reaction will not occur because nickel is below calcium in the activity series. So this would be a no. And if, like I said, if you want to practice balancing, you could balance this equation. Otherwise, you could just leave it since it will not occur. Now, if the element by itself is on the right-hand side of the series, like in H, then you have to find something that is on the same side of the series as bromine to determine if it will occur or not. Okay, so that's the process. And now I want to show you guys a reaction, and I'm actually going to write it down here so we can see what you're going to be looking at. You're going to be watching a reaction now between copper and silver nitrate. Okay, so copper is here in our activity series. Let me erase this. And silver is down here. So this reaction will occur because copper is higher than silver. So in this reaction, you're going to see that copper is going to form copper 2 nitrate. So like I said, you can always assume it's a +2 charge if it's a transition metal when it forms a compound in the product. And then silver is by itself. Okay, so I'm going to show you that video. And what you see in this video here at the beginning is this beaker filled with silver nitrate in solution. The scientist is then going to add a piece of copper wire, and copper is by itself, and we're going to see what happens as copper replaces silver in the compound. Remember, copper is higher on the activity series than silver. Silver, as you're going to see, is going to end up being by itself, and then copper nitrate will then be in the solution. So watch what happens. Okay, so you're going to notice almost right away that the copper wire is starting to turn kind of grayish. That is actually silver that is being kicked out of the silver nitrate and then forming solid silver on the copper wire. And you're going to see the silver crystals kind of grow over time and get larger and larger. And they've sped this up because this can be kind of a slow process. So, and what you can also notice is that the solution itself is starting to turn blue, because when copper nitrate is dissolved in water, that solution would be a blue solution. So that's actually copper nitrate going into solution and those silver crystals growing on the copper wire, the silver being kicked out of the silver nitrate. And when you're done, you can actually get the wire out of here and kind of scrape those silver crystals out off of it, and you have pure silver. It's very pretty. And there's the reaction. Copper plus silver nitrate goes to silver, and copper to nitrate.